Welcome to all. Now I am going to take Unit 4 Hydrogen. For this unit, we are going to study about preparation, chemical properties, physical properties, uses of hydrogen, hydrogen isotopes, and its compounds. In this session, we are going to discuss about introduction of hydrogen, different isotopes of hydrogen, preparation of hydrogen and its isotopes. Hydrogen. Small introduction about hydrogen. The air all around us, the water we drink, the cells of our body, a plastic cup, and many other objects all around us, all of these have one thing in common. They contain hydrogen. Yes, hydrogen is a most common element in the universe. The giant planets such as Jupiter and Saturn containing mostly hydrogen. It is the third most abundant element on the surface of globe. It is one of the elements that make up every organic compound and is also a part of many inorganic compounds. So it is a most abundant element. Next property is it is very hydrogen is so light. So it is extremely rare to find on its own nature on Earth, but it is very common to find in outer space. Since hydrogen is so light, free hydrogen can easily escape the atmosphere. But hydrogen is also very reactive, so if it does not escape the atmosphere, it will react with the other compound and can no longer be found free. So to naturally find hydrogen on Earth, we must look for it in other compounds. It is part of many reactions and many compounds like petroleum, mineral, cellulose, starch, sugar, fat, oil, alcohols, acid, and thousands of other substances. And hydrogen is the simplest element. Yes, that is consists of only one proton in the nucleus and only one electron in the outer orbit. So symbol of hydrogen is H. Atomic number of hydrogen is 1. Atomic number means the number of protons in the nucleus. Mass number of hydrogen is 1. Mass number means the whole number of sum of the protons and neutrons in the nucleus. Atomic mass of hydrogen is 1.0079. Atomic mass means the mass of the atom weighed across its isotopes. Yes, hydrogen is a chemical element that exists as a gas at room temperature. That means at normal room temperature, hydrogen is as a gas. When hydrogen gas burns in air, it forms water. So scientist Antony Lavoisier named hydrogen from the Greek word for water former. Hydrogen gas is the smallest atom of any element. A hydrogen atom contains one proton and only one electron. That proton is present at the center, that means nucleus, and the electrons revolves around the nucleus. Normally, pure hydrogen exists as hydrogen gas in which pair of hydrogen atom bond together to make a molecule that is called as hydrogen molecule. Next topic is isotope of hydrogen. Hydrogen has three known isotopes. Isotope means one of two or more species of atom of a chemical element with the same atomic number and position in the periodic table and nearly identical chemical behavior but different atomic mass and physical properties. Simply atoms that have the same atomic number, that means number of protons are same but different mass number, that means number of protons and neutrons are different, that is called as isotope. So hydrogen has three different isotopes. One is hydrogen. Mind it, isotope means same atomic number. So atomic number same, mass number different. First one is hydrogen. Atomic number 1, mass number also 1. Atomic mass 1.008 AMU. Second one, atomic number 1, mass number 2, atomic mass 2.014 AMU. Third one is mass number 3, atomic number same, that is 1, atomic mass 3.016 AMU. First one is protium, that is a ordinary hydrogen with one proton and no neutron, that is called as protium. That means atomic number 1, mass number 1, which containing one proton and no neutrons. Normally, protium is the predominant form, that means 99.985%, and it is the only isotope that does not containing a neutron. Second one, deuterium. Atomic number 1, mass number 2. It contains one proton and one neutron in its nucleus. It is stable hydrogen isotope that is called as deuterium. Atomic mass 2.014 AMU. The nucleus of deuterium is called as deuterion. Deuterium is also known as heavy hydrogen because the mass number is double compared to protium. That is consists about 0.015% in Earth. Deuterium is not radioactive and does not represent a significant toxicity hazard. Water enriched in molecule that include deuterium instead of protium, that is called as. Next isotope is tritium, atomic number 1, mass number 3. It contains one proton and two neutrons in its nucleus. This is known as tritium. Atomic mass 3.016 AMU. It is radioactive. Half-life time of this isotope is 12.32 years. Tritium is a radioactive isotope of hydrogen, so that is only occur in trace quantity. Trace amount of tritium occurs naturally because of the interaction of cosmic rays with atmospheric gases. Now we are going to compare the properties of hydrogen, deuterium and tritium. Symbol H for protium, deuterium represented by D, tritium T. Atomic mass of protium 1.008, deuterium 2.014 AMU, tritium 3.016 AMU. Number of electrons present in protium is 1, protons 1, neutrons 0. Deuterium, number of electrons 1, number of protons 1, number of neutrons 1. Tritium contains number of electrons 1, number of protons 1, number of neutrons 2. Nuclear stability, protium and deuterium are stable. Tritium, that is a radioactive element, so half-life time is 12.3 years. Molecular hydrogen, that is represented by H2, deuterium D2, tritium T2. Abundance in earth crust, protium presented 99.985%, deuterium 0.0156%, tritium 10 power minus 15%. Molecular mass of protium 2.016, deuterium 4.028, tritium 6.032. Remaining everything is physical properties also given. Melting point, boiling point, internuclear distance, critical temperature, enthalpy of dissociation values also given for this table. Next, preparation of hydrogen. Hydrogen is prepared by electrolysis method. Second one is laboratory preparation. Next one is industrial production. First method is electrolysis method. High purity hydrogen, nearly 99.9% is obtained by electrolysis of water. Here, water containing trace of acid or alkali is acted as an electrolyte. Pure water does not conduct electricity. So here we are mixed with some quantity of or small quantity of acid or alkali to the water, that is act as a electrolyte. Nickel is act as a anode. Iron rod is act as a cathode. For this electrolysis process, hydrogen is liberated at cathode, oxygen is liberated at anode. Overall reaction H2O gives H2 plus of O2. Next method is laboratory preparation. This is the diagrammatic representation of preparation of hydrogen. For this process takes place four steps. First one is take a few gram of zinc granules and place it in a 500 ml flask. Second step, with the help of the thistle funnel, add diluted hydrochloric acid to the zinc granules. Hydrogen gas will be automatically collected with the help of the delivery tube via the downward displacement of water. General reaction takes place diluted acid with metal, that is produce salt of metal and acid plus hydrogen gas is evolved. Suppose hydrochloric acid reacted with zinc, that is produce hydrogen. Suppose you are using sulfuric acid, that is also produce hydrogen, but metal salt is zinc sulfate. Finally, hydrogen gas can be collected by the downward displacement of water because hydrogen gas is lighter than water. Next method is industrial production. Hydrogen is produced by steam reforming of hydrocarbons. In this method, hydrocarbon such as methane is mixed with steam and passed over a nickel catalyst in the range 900 to 1000 degrees Celsius and 35 atmospheric pressure. Here nickel is act as a catalyst. Catalyst means that is does not take part in the chemical reaction, that is alter the speed of the chemical reaction. Here nickel is act as a catalyst. Here that is increase the speed of the chemical reaction. So hydrocarbon involved for the reaction with steam in the presence of nickel. Nickel here is act as a catalyst, that is produce carbon monoxide plus hydrogen. Another one way also we are producing hydrogen gas. Steam is passed over a red hot coke to produce carbon monoxide and hydrogen. The mixture of gases produced in this way is known as water gas. That means carbon monoxide and hydrogen mixture is called as water gas. This is also called as syngas, otherwise synthetic gas, that is used in synthesis of organic compound such as methanol and simple hydrocarbons. Preparation of hydrogen is over. What are the methods we are used to prepare hydrogen? First one is electrolysis method. Second one is laboratory preparation. Third one is industrial production. In the electrolysis process, we are using water containing trace of acid or alkali as a electrolyte. Nickel anode. Iron rod is used as a cathode. In the laboratory preparation, we are taking any one of the highly reactive metal and then reacted with diluted acid, that may be hydrochloric acid or sulfuric acid, that is produce hydrogen. Third method is industrial production. Here we are using steam, that is mixed with methane or red hot coke to produce hydrogen. Next we are going to discuss about preparation of deuterium. Deuterium is prepared by electrolysis method. When water is involved for electrolysis, hydrogen is liberated. Already we have studied this. Okay, but here we are taking as a heavy water that is involved for the electrolysis, but we are not able to directly take heavy water. First, we are taking a ordinary water. That water is involved for the electrolysis. Hydrogen is liberated much faster than deuterium. The electrolysis is continued until the resulting solution becomes enriched in heavy water. Now our water, normal water is converted into heavy water and then again involved for electrolysis that heavy water produce deuterium. So one and only method of preparation of deuterium, that is electrolysis method. Here we are taking water is a electrolyte. Electrolysis processes continue until the resulting solution becomes enriched in heavy water. Further electrolysis, heavy water is produced deuterium. Next is preparation of tritium. Tritium is a radioactive element, so it is prepared by artificially by bombarding lithium with a slow neutron in a nuclear fission reactor. That is a nuclear reaction. You are well known, tritium is a radioactive element, so it is prepared by bombarding lithium with slow neutron. That reaction takes place in nuclear fission reactor. That reaction is lithium Li36, atomic number 3, mass number 6, that is bombarded with a neutron. Neutron atomic number 0, mass number is 1, that is converted into helium plus tritium. So hydrogen is the only element that has different names for its isotope in common use today. During the early study of radioactivity, various heavy radioactive isotopes were given their own names, but these names are no longer used except for deuterium and tritium. Thank you.